sum of one or more terms. X squared plus 3x minus 4 with no division and no fractions. What's a polynomial term? It can be a number like 4, can be a variable like x, a number and a variable multiplied together, 3x. With no addition and no subtraction and with no negative exponents, that is a polynomial term. What's a monomial? It's a polynomial with one term. 2xy squared, one term, a monomial. What's a binomial? It's a polynomial with two terms. 2x plus 4, two terms, a binomial. What's a trinomial? It's a polynomial with three terms. X squared plus 5x plus 6, three terms, a trinomial. What's the degree of a term? The degree of a term is the exponent of the variable. X squared degree 2, 5x degree 1, 6 degree 0. What's the order? Put the terms in order from the highest degree to the lowest. X squared degree 2 first, 5x degree 1x, 6 degree 0 is last. That's a polynomial. That's a polynomial.
All right, well, welcome back to Algebra 1 Big Ideas curriculum. And we are now looking in Chapter 7, where we're going to be looking at polynomials and working with polynomials, doing operations with them. As you can see on our first lesson here, 7.1, we are adding and subtracting polynomials. And that video was just, I thought, was a great introduction to the polynomials. It really gives you a lot of information in that video. Really a lot of what we're going to be talking about here in this lesson, but we also are going to go on to adding and subtracting polynomials as well. We'll be doing other operations like multiplying as well with polynomials, and then eventually we'll get into factoring the polynomials. So starting with our cartoon, let's go ahead and look at that. So here's our far side, in a classroom. Well, here we go again. Did anyone here not eat his or her homework on the way to school? The whole class is full of dogs. Obviously, you know, they always excuses, dog ate my homework. All right, let's go on. That's a great cartoon. I love that one. All right, take a look at page 206 there in your notes. You have some vocabulary. Monomial is the first one. The video is very clear on that monomial. It is just, we talk about polynomials. Poly, the word poly just means many. Mono means one. So a monomial is just it's a polynomial with one term. So you can see here that the monomial is a number, a variable. So it could be a number, like I said, it could be 4, it could be a variable, it could be x, or the product of a number and one or more variables. That's what you want to put down. Let me underline that with you. So it's right here, a number, a variable, or a product of a number and one or more variables with whole number exponents. So it can't have fraction exponents. It cannot have negative exponents. Now I put down here, and you want to write this down here as well, I think would be helpful. A monomial is one single term. There's no plus or no minus symbols in it. And so you can kind of see down here, monomials, these are examples of monomials, all single. It's like could be a 10, it could be a 3x. And so a number times a variable, it could just be the x by itself. It could be where you have a fraction in front of like a, b squared. You could even have a decimal in front of m to the 5th power. So those are all examples of a monomial, all single terms, one term. Here's examples of things that are not monomials. It cannot have any plus or minus symbols in there, like 5 plus x. That's not a monomial. That would be still a polynomial right there. That would be called a binomial. 2 over n is not a polynomial at all because n's at the bottom. N could be at the top of a fraction but never at the bottom. So it cannot be, the variable cannot be in the denominator. You cannot have the variable as an exponent either. 4 to the a power, that doesn't work either for a polynomial. And you cannot have any negative exponents either. X to a negative 1 wouldn't work either. So these are all examples of what's not a polynomial. When we talk about the degree of a polynomial, so the degree, just the degree of the monomial, again, it's the sum. So right here, the degree of a monomial, this is what you want to write down, is the sum of the exponents of the variables in the monomial. So the sum of them. Now, if it only has one term, you're really not doing a sum. It's just whatever that exponent is the degree. But you could have something like this where you have an a and a b squared. So the a has an exponent of 1, and then the b squared has an exponent of 2. So 1 plus 2 would give you 3. That would be the degree. If it is just a constant number, like 10 here, or 4 like the video showed, it's just a degree 0. Okay, because this would be like x to the 0 power would be 10. And so it's just a degree 0. When it's right here, just have an x. There is no power. It doesn't show you a power. You assume it's a 1. So it would just be degree 1. This one just only has a 5 on it. There's no other term, no other variable terms that have an exponent, so just 5 on that one. All right, let's move forward to our next part here. We're going to try some practice here on 207. So extra practice. It says find the degree of the monomial. These are all examples here of 1 through 8. These are all examples of monomials. And so we just want to find the degree of them. So I'll do maybe some here that are, I'll do the even ones and you can come back and do the odd ones. So let's do the even ones together here. Number 2, it just says w. Okay, w, the variable by itself. So we assume the exponent is a 1. So that would just have a 1. W to the first would be degree 1. So we'd see that's our degree for number 2. If we're going to look at 4, 4 has A, B, and C. So A has a 1, B has a 1, C has a 1. And so you're going to add all of those up. 1 plus 1 plus 1 would give you 3 for the degree of the polynomial or the monomial. So these are all monomials, one single term. So the degree is the sum of all the exponents of the variables. So 1 plus 1 plus 1 would give you degree 3. If we look at number 6 here, so you have an r, an s, and a t. T would have a 1 right there. So you have r squared, s to the third, t to the first. 2 plus 3 plus 1 would give you 6. So the degree would be 6 for number 6 here on this one. And then problem number 8, we have 2/3. So it is a fraction, and that's okay. A fraction can be a polynomial, it could be a monomial. But this one doesn't have any variable. If it has no variable, it would just be degree 0. It's a constant. Okay, so this would be a constantly 2/3. It's called a constant term. And so this is going to be degree 0. Any constant term with no variables attached to it is just going to be degree 0. So go ahead and pause the video and then just do 1, 3, 5, and 7, these odd ones here. Get the degrees for those and then just check your answer. All right, let's go ahead and check our answers for 1, 3, 5, and 7. So number 1, it just has an s to the first, so that would be degree 1 on this one. The negative 6 doesn't do anything. It's always the variables, the exponent for the variable. 8 is a constant, so it's going to be just like number 8 down there. It's going to be degree 0. Number 5 has an x and a y. The y would have a 1. So it's going to be 2 plus 1 for those exponents. That's degree 3. Again, the 7 has nothing to do with any of this. The numbers in front of these variables, we would call those coefficients. Coefficients, and you probably, if you haven't written this down or you didn't know that already, I would write that down. The numbers in front are called coefficients. So number 7, there's a coefficient of 10. That has nothing to do with the degree though. We have m to the first power and then n to the third power. 1 plus 3 should be degree 4. So again, it's the sum of the exponents on the variables that would give you the degree for that monomial. All right, let's move on to our next section, where we're going to look at now classifying polynomials. Again, the video was very good in showing you this as well. We just classified what a monomial was. A monomial is a polynomial with just one single term. But then we could also see something called a binomial and a trinomial. Binomial is when it has 2 terms. Trinomial is when it's got 3 terms. Now, since you have a core concept with all of this in here, just go ahead and highlight these here so you can just highlight them in the core concept. You don't need to write them all down. But what I would do here is write down this. For a polynomial, again, poly means many. So a polynomial typically does have more than one term in it and will have plus or minus symbols. The only time it doesn't is when it's a monomial, and so that's why we kind of try to keep those separate. Monomials are kind of separate. They're just single terms. But if it's a polynomial, that means it could be a binomial, a trinomial, or it could have 4 terms, 5 terms. This one's got 4 terms in it down here. There's not really any name for anything past 3. So if we have 2 terms, we call it a binomial. 3 terms, we call it a trinomial. But once we get to 4 terms, we just say a 4-term polynomial. We just call them polynomials then and name it by how many terms it has. This is a 4-term polynomial down here at the bottom. So again, here is the leading coefficient. There's that word I said. So the term has leading coefficient. So the coefficients are the numbers in front of the variables. It's got your degree. That would be degree 3. This is the degree of that one. This would be degree 2, degree 1. It showed you how to put them in order. Now we want to always put them in standard form, and that's what this is talking about here. So the degree of a polynomial is the greatest degree of its terms. And if you can put them in standard form, that's usually the first one. Standard form is when the exponents of the terms decrease from left to right. So it starts with 3 here, then 2, then 1, and so on. So typically we keep the highest degree at the beginning, then the next highest degree, and just keeps on going down from there. And again, number 12. The number 12 here is called our constant term. It has no variable. We would call that a constant term. It's a degree 0 term. The leading coefficient is the one that's the leading term. So here's your leading term. That's usually the very most important term here on the polynomial. So the leading coefficient is 2, and the degree for this leading term is degree 3. So in this case, the degree of the polynomial would be a degree 3 polynomial, because that's what this says here. The degree of a polynomial is the greatest degree of its terms. Again, I would maybe underline some of this part right in there for your vocabulary. So since the greatest degree of all 4 of these terms, there's 4 separate terms here. This has the greatest degree, so it's the degree of the polynomial. All right, let's move on to looking at some more here. We're going to just go ahead and watch this to see how we're going to do this, and then I'll give you a chance to try this on your own. It says write this polynomial in standard form. It's not in standard form right now. That means we need to order it from highest degree to lowest. Then identify the degree leading coefficient of the polynomial. So the highest degree would be the degree 3. That should go first. It would be negative x to the third first, and then the 15x, then the constant number would be last. And so we can see that here it is. Degree is 1 right now. Degree is 3 of this one. Degree is 0 of the last term. So it shows you the degree of each term. And so if we were to put it in order from the highest degree, that's why this one's got to go first, then this one would go next, our constant would go last. And so it's negative x to the third plus 15x plus 3. It talks about the leading coefficient. The leading coefficient is a negative 1. That's what's in front of our leading term here. Degree of the polynomial is 3. That's the highest degree of the terms. Here's another one that we can just watch. Write each polynomial in standard form, identify the degree, and classify each polynomial by the number of terms. So again, we have right here polynomial, so the name, standard form, degree, and type of polynomial. We're going to do this in just a moment on our extra practice. And so for the letter A, you can see the polynomial for this one is standard form for letter A is just what it is, because it's a monomial. It's degree 4. We call it a monomial. So there really is no standard form other than just what it is, because it's just one single term. For this polynomial here, okay, for B, here's our polynomial problem. Standard form would be putting the x squared first, and then the x term, then the constant number last. The degree is the highest degree, which would be 2 in this one, and it's 1, 2, 3 terms. We call it a trinomial. And our number C1 here, q to the 5th is going to be going first, because that's got the highest degree. Q to the 5th, then the 8q. So put it in order from highest degree to lowest. And then the degree of the polynomial is 5. That's the highest degree. And there's 2 terms, so we call it a binomial. All right, let's go on to our extra practice where we're going to do just exactly what we see here. So for each one of these 9 through 12, we're going to write it in standard form. We're going to put the degree. We're going to also identify the leading coefficient and then name the type of the polynomial. So it's either going to be monomial, binomial, or trinomial. We don't have anything bigger than 3 terms here on this one. So I'm going to go ahead and do number 9, and then you guys can do the rest of them and check your answers after that. So standard form for number 9. The highest degree would be 2, so it's got to be first. This is got to be our first term, then the x, then the 5 will be last. So there's our standard form, what we should write there for standard form. That's just the order from highest degree to lowest. 5, the constant, always has their lowest degree because it's degree 0. The degree of this polynomial, highest degree is 2, so degree, it's a degree 2 polynomial. The leading coefficient, here's your leading term, this 3x squared, the leading coefficient is the 3, the number in front of x squared. The type of polynomial, since it has 3 terms, it is a trinomial. All right, so go ahead and pause the video and do 10, 11, and 12. Do the same thing. Make sure you write standard form, the degree of that polynomial, the leading coefficient, and the type. So do that for all 3 of those, and then check your answers once you're finished. Okay, let's go ahead and check our answers here for number 10. So number 10, it's just a single term, so it is what it is. There's nothing we can, there's no other order than what it is. It's just one single term. And the degree, the y has a 1 here, so it's a degree 1 polynomial. The leading coefficient is a square root of 5. Now, it's okay that there's a square root of 5 as a coefficient. You just cannot have a square root around the y. The y can't be under a square root sign there. So the 5 is okay to be in front. That's okay that the coefficient's a square root, and since it's a single term, we call it a monomial. Number 11, for this one, standard form, we're going to put the second one first here because it's got the x to the 8th. That's bigger than x to the 5th. So just reverse the order there between the two of those. And then the degree is the 8 because that's the highest degree of its terms. Between these two, it's 8 is higher. So it's degree 8 polynomial. Leading coefficient is a 6. That's the leading term with the degree, the highest degree, and 6 is the coefficient. And since there's 2 terms, we call it a binomial. Number 12, putting this in standard form, the fourth, f to the 4th has to go first, then f to the 2nd power, then f to the 1st power will be last. So that's the right way to put it in order. F to the 4th plus f squared minus 2f. Make sure you get the plus and minus symbols correctly put in. And it's 4 is the highest degree of all the terms, so it's the degree of the polynomial. There's a 1 in front of f to the 4th, so that's the leading coefficient, and there's 3 terms, so we would call it a trinomial. All right, so not too hard, just to identify some of these things. We definitely always want to put them in standard form. That's the best form to see these polynomials in. All right, let's move on to now our next part here. And before we get to the next part, let's just pause for our joke of the day. Here it is. It says, why can't you hear a pterodactyl go to the bathroom? So that's that dinosaur bird, right? I've seen that in Jurassic Park, perhaps. So why can't you hear a pterodactyl go to the bathroom? Well, because the P is silent. Their P is silent. Pterodactyl, right? You don't say pterodactyl. You don't see the P. Pterodactyl. All right, that's funny. The P is silent. Okay, now let's head on to sums and differences. So we're going to add and subtract polynomials now. So we're going to see how we have 2 polynomials here with an addition sign between them. If we were to add the polynomials together, all we're going to do is just combine like terms. That's all we do. So we look for the like terms. They have to end the same. So x to the thirds, when they end the same, so here we got some, we could do it this way. There's a vertical format. You can kind of line them up, in fact. So this is one way to kind of do it. So here you can line up and then combine like terms going down in the columns. So you have your x to the thirds. They would combine to 3x to the third. Negative 5 and positive 2 would be negative 3x squared. And then this one just comes down, nothing to combine with the 1 either. So that's one way to do it. You can do it in a vertical format. You could also do it in a horizontal format, and this is the one I typically use most of the time, is just seeing it like this, where I'm going to put the x squareds together horizontally like this, just put them in a parenthesis. See, I'm going to be adding those terms, the x and the 4x, we could do it that way. Then we're doing b here. We're doing b in a horizontal format. And then we would have our constants together as well. So these two combine to 4x to the fourth, and then these two 5x, and then these two just to give us a 4, and there it is. So that's typically the way I would probably do this. Now, we're going to go 13 through 16. So what I'd like you to try to do here for 13 through 16 is pause the video and try these on your own. You could either use the horizontal format or the vertical format. I'm going to kind of show more the horizontal format though for 13 through 16. And you're just going to combine like terms here. That's all you're doing to add these two polynomials together. Find the sum. So see if you can just combine like terms. In fact, I'll show you the first one here and then you can do the rest. So let's do 13 together. So the first one, I would combine the x terms together, the negative 4x plus a 6x. That's what I'm doing in the first term. And that would give me, right here, between these two, I'm going to take 4 away from 6. That would give me 2x there in the answer part. And then for the 9 and the 14, 9 minus 14. 9 plus a negative 14 is going to be a minus 14. 9 minus 14, so if I take 9 away from negative 14, that would leave me with a negative 5. So there's my answer for number 13. It's just a 2x minus 5. So go ahead and pause the video and do 14, 15, and 16, and then play to check your answers. Okay, so hopefully you're able to do these okay, and now you're checking your answers. If you make a mistake, just go ahead and fix it on your paper. There's no trouble to make a mistake. It's the way we learn. So for 14, we're going to put the a's together, the two a terms. Those are like terms. So we're going to see the negative 3a from this one plus 7a. Okay, when I combine those together, take negative 3 away from 7, that's a positive 4a. So that's the first part of my answer. And then the negative 2 and the positive 5. So it's going to be negative 2 plus 5, because you have a plus and a plus here, still going to be a plus. So if I take 2 away from 5, it's going to be a positive 3. So 4a plus 3 should be our answer for 14. For 15, we have x squared on this one, plus a negative x squared on the other one. So they have extra x squares are like terms. So plus a negative x squared is just going to be minus x squared. So we're going to see x squared minus x squared. So those cancel each other out. So that's going to be x squared and negative x squared cancels each other out. Notice I do not have any red one down here in my answer. So there's nothing from this that's going to be in my answer. Then the next ones I would see would be the 3x and the 6x. So 3x plus a 6x. So that's going to give us 9x when I combine those two together. So 3 plus 6 is 9x. So actually we start this way now with this term 9x. And then the constant 5 plus a negative 4. So plus a negative 4 would be a minus 4. So it's 5 minus 4, and then that would just give me 1. So plus positive 1. 9x plus 1 should be our answer for number 15. For 16, we got these t's. Now, you got to realize that these are not in standard form. I think everything so far in here was in the correct order for standard form, but these are not in standard form. So as we're kind of combining like terms, we want to combine them where we start with the highest exponents. The highest exponent that we see in either one of these is t to the third power. So we want to start there. So this is going to be 3t to the third plus negative 2t to the third, so it's just a minus t to the 2t to the third. So 3t to the third from the first one, and then plus a negative will be a minus 2t to the third. So if I take 2 away from 3, that leaves me with just 1t to the third here in the answer part. Now we go on to t squareds. So there is a t squared in this one, plus 2t squared in the second one. And so you combine those two together, they're just 1 plus 2, so it's a 3t squared next in our answer. Again, our answer needs to be in standard form. The next term would be a t by itself. There's no t's in this first one, but there is a t in the second one, so it's a plus positive 7t. So it's a positive 7t, or just 7t here. So we got to put plus 7t in this next part. So that just comes down the way it is. And then there is a constant negative 3 here, but there is no constant numbers in the second parenthesis. So it's just going to be negative 3 for that constant term, nothing to combine with it. So that minus 3 just comes down in our answer at the end. So it's a 4-term polynomial for that one. Once we're finished, we get it in standard form. All right, so we've gotten sums done now. So this was adding polynomials. We see the plus sign in between the two polynomials. We're going to now go on to difference, and we're going to subtract polynomials. We're going to see no longer a plus here, we're going to see a minus, and that does change things a little bit. It's very similar, but it does change some things a little bit. So here now we see the minus signs in front. So there's a couple things that we could do. We could start with just distributing the negative, changing all the signs in the second parenthesis. So distribute negative and change all these signs, and then we just combine like terms like we did with finding the sum. Or we could try to just subtract them as we go along. So again, we could do vertical format. Now I don't typically do vertical format here, but you can see that's what they're going to do. They're going to distribute the negative to this one, and that changes all of the signs. All three signs just change to their opposites. And now they have things lined up. They lined up like terms, so the n squared's lined up. There's nothing to combine with the n term. That's going to be in our answer the way it is. And then the 5 and the 4 are lined up, and that gives you your answer when you combine like terms. So this is one option. You can do it this way. You can do the horizontal format, which is the one I'm typically using. So we could do it this way. We could distribute the negative first, like this one did. So this becomes now negative 3x squared. Negative times negative is positive x. Negative times negative is positive 8. So I changed all the signs of this red one, and now we just combine like terms like we did earlier with finding the sum. And then once we combine like terms, these two combine to x squared, these two x's combine to negative 2x, and these two constants combine to 13. So there's your answer on that one. Again, always answers are in standard form. All right, let's take a look at our extra practice. The last few problems here of our extra practice is find the difference. So number 17 through 20. So what we want to do on this one is subtract. We could use either the horizontal format or the vertical format. Whichever way you like better is fine. I typically use the horizontal format. So let me show you what I'm going to do here on number 17, and then again you can do 18, 19, 20 on your own, to try those on your own first. So the g and the 3g. So we have basically a g minus 3g on this one, because this is going to become 3 or negative times a 3g. So g minus 3g is what we're going to combine together. This is a 1g, so basically 1 minus 3 is going to give us negative 2g for the first part. Then for the constants, we have negative 4 minus negative 6. You got to distribute this negative. Negative times negative will make this a positive 6. So you're going to see it's negative 4 plus 6 that we're really combining. So we're going to combine negative 4 and a positive 6, because you distribute negative times negative to give you a positive 6. So if I take 4 away from 6, that's a positive 2 right there. So negative 2g plus 2 gives me the answer of the subtraction there for number 17. All right, go ahead and pause the video and try 18, 19, and 20. And make sure, again, your answers should be in standard form. And then play it once you're done to check your answers. All right, so hopefully you do have answers for these three problems. And again, if you make a mistake, that's okay. Just fix it on your paper as you see what we should have here for our answers. It's easy to make simple mistakes. I do them all the time myself. So I gotta always just be careful, and I gotta double check myself on everything I do. So starting with the h's here, negative 5h, and then we have a minus 7h. So the sign here, minus 7h. So that's what we see in our first parenthesis, negative 5h minus 7h. So since they're both the same sign, we're going to add the numbers and keep it negative. So this is going to be 5 and 7 make it 12, so negative 12h for our first term. Negative 2 minus a positive 6. So negative 2 minus 6 is what we're going to combine here. So the negative 2 from the first one minus the 6. So that's going to be, since they're again the same sign, we're going to add these two numbers, keep that negative. So it's going to be a negative 8 for our second term. There's our answer, negative 12h minus 8. Number 19, x squared is the first term. So we have negative x squared, then a minus negative 3x squared. So that's negative times negative That will turn this into a positive 3x squared here. So negative x squared plus 3x squared is what we need to combine. So you got basically taking 1 away from 3 is going to be positive 2x squared for the first part of our answer. The next part of the problem would be x. So you have x squared. An x term would be next, but there is no x term in the first parenthesis. There's only an x term in the second one. So we can't just put negative x squared here. We got to, again, think negative times negative. We got to distribute this negative to these 3 ones in the second one. So negative times negative is positive x squared. So there's a positive x squared for the second term in our answer. And then the constant numbers, you have a negative 5 minus negative 8. So negative times negative there will make that a positive 8. Negative 5 plus 8. So if I take 5 away from 8, that's going to give me a positive 3. Again, it's in standard form. Highest degree there is 2. That's the degree of the polynomial is 2. The leading coefficient would be 2. It's in standard form as they are descending from highest degree to lowest. And then number 20, our last one here. Starting with, we've got to look for the highest exponent. That's k to the third. So k to the third, even though these are not in standard form originally, we're going to write it in standard form in our answers. So start with the k to the third. So 6k to the third in the first one minus negative 3, actually that's not the case, it's this one here, k to the third, minus 5k to the third in the second one. So it's 6k to the third minus a 5k to the third. So k to the thirds combined together, take 6 minus 5 is just a 1, so 1k to the third, or just k to the third, is the way we would start this. K squared, there's a k squared in this first one, and there is k squared in the second one, but it's minus negative 3k squared. So minus a negative will turn this into a positive. So it's going to be k squared plus 3k squared. So your k squareds combined, 1 plus 3 gives me 4k squareds. Now the next term would be the k term. There is no k term in the first parenthesis. There is a k term in the second one, but we got to subtract it. It's a minus 7k. So it's a negative 7k. So the next term after the 4k squared is a negative 7k. So there's no other things to combine with it, but we do need to see that we're going to have to distribute the negative and change this positive 7k to a negative 7k as we put it in our answer. And then our constant, there's a constant in the first one, negative 4, but there is no constants in the second one. So it's just going to be negative 4. We're not subtracting anything else after that. So just minus 4. And so there's a minus 4 at the end of that. All right, so finding the sum, finding the difference, they are very similar. You're going to combine like terms. You either combine like terms with addition, there on the sum, or subtraction. You got to make sure you're going to subtract and change the signs of the second parenthesis when you're going to do this subtraction. All right, so that's it for 7.1, and that's our kind of our introduction to polynomials. We're going to be talking about polynomials the entire chapter for chapter 7. All right, guys, I'll see you on the next lesson. Have a great rest of your day.